In this lecture, we will talk about how to find the partial fraction decomposition for the rational expressions. You see here we have a rational expression 15 over 4x times quantity 5x plus 3. We want to decompose this rational expression into a simple one, a over x plus b over 5x plus 3. Why do we need to do so? It's because, in calculus class, in order to find out the integral of this one, you have to decompose this a little bit complicated one to a simpler one. So you see a over x looks much more simpler than this one, plus another one, b over 5x plus 3, that's more simpler than that. And then we should be able to find out easily the integral for both of them. Okay, that's the reason. Now here we have a variable x and 5x plus 3, so we know this fraction can be decomposed into these two. The thing is that we need the constant a and b. We don't know what a and b are at this moment. So what we know we can proceed is that if both numerator and denominator multiplied by 5x plus 3, and the second one multiplied by x over x, then you see x times 5x plus 3, 5x plus 3 times x, they will have the same denominator. Now, if they have the same denominator, then we know we can add numerators together. That will be what? That will be, for the first one, is a times 5x, so you have a 5ax plus 3a. That's the first one. The second one is just b times x, so we want to add those two together. We add those two together, here is 5ax, and here is bx. They are like terms. So we pull x out, and then we have a 5a plus b, because x is out. So 5a plus b. And the constant term is 3a. So that's the way we add numerators. Now, denominator, that's x times 5x plus 3, we keep it. You see, they have the same denominator, so we keep it. Now, we're going to compare 5a plus bx plus 3a with the original one to see what's the difference. Apparently, in this one, there is no term contain x. 5a plus b times x, comparing to this one, because here the constant is 15 over 4. Then we know this one, 5a plus b, has to be 0, because 0 times x is 0. So then you get this term disappeared. Okay, so basically what we get is, first one is 5a plus b is 0. The second one is 3a equals 15 over 4. Remember, here we have x times 5x plus 3 without 4. Okay, and we know here 15 over 4 is a constant. So what we do is like this. So you see, so 3a is 15 over 4. And then 15 over 4 equals 3a, both sides divided by 3, we may cancel this 3 upstairs and downstairs. And then we have 3 divided by 3 is 1 times a, so we have a left hand side is a. Right hand side is 15 divided by 3 is 5, and 4 is downstairs. So we then have a equals 5 fourths. Alright, you put it back here because we know the value a now. That's 5 times a, and a is 5 over 4. So 5 times 5 is 25. You know, downstairs we know 5. Below 5 we know is 1. So 1 times 4 is 4. So we have this one. 25 over 4 plus b is 0. Both sides, you know, subtract 25 over 4 on both sides. So you get those two cancelled. And b stands alone on the left, and negative 25 over 4 stands on the right. So we then have a b value, which is right here, and we then have an a value, which is right here. So what is our a? A is 5 over 4. So you write like that. 5 upstairs, 4 downstairs. Okay, times x. So downstairs is 4x, upstairs is 5. Now, for b, what do we get? We get negative 25 over 4. Again, then negative 25 goes upstairs, and downstairs is 4 times the quantity 5x plus 3. And this is the final answer. Okay? Alright. That's the first example. The second example is like this. The one right here. That's 4x squared minus x minus 13 over x times x plus 1 times x minus 1. Now we know that x plus 1, x minus 1, 3 products. Then we know that will be like this. x plus 1, x minus 1. Upstairs is a, b, c. They are all constants. Okay? Now, how we are going to add all those 3 together? You see, we need to make denominators be the same. This one is only x from here, and then x plus 1, x minus 1 has to be multiplied to both numerator and denominator. This one is from x plus 1, so it needs x and x minus 1 on both numerator and denominator. This one we chose from x minus 1, so then denominator and numerator needs to be multiplied by x times x plus 1 and x times x plus 1. Both numerator and denominator. Alright, then in this way we get all denominators are the same. Goes back to there. So our business is to add all the numerators together and find the equations. We know x plus 1, x minus 1, you do by FOIL. Okay, x times x, that's x squared. X times negative 1 is negative x, and x times 1 is plus x, and 1 times negative 1 is negative 1. So those two will be cancelled. What you get is x squared minus 1 times a for numerator. And you know, that's what I wrote here. You see here, a times x squared minus 1. The second one is b times x is x squared, x times negative 1 is negative x. Okay, and then the third one is c times this quantity, and we know x times x is x squared, x times 1 is x. So c needs to multiply this quantity. Alright, denominators, they're all the same. Okay, now let's put numerators together. Numerators, a times x squared is ax squared, a times -1 is -a, and then b times x squared is bx squared, b times -x is -bx. C times x squared is cx squared, plus c times x is cx. Again, denominators are the same. We don't do anything with denominators. Now, look, combine like terms. X squared c, b, x squared b, and x squared a. You combine all of three, you pull x squared out. What you get is here. So x squared is out, and a, b, c is actually the coefficient now. And then we do is, here the degree is 1, here the degree is 1, we need to combine those. We pull x out right here, and here is -b, and then plus c. Okay, the last one is constant, -a. So we have -a. After we get this far, right here, we then compare with the original one. The original one is a plus b plus c equals 4, because, look, x squared, okay, and then x squared. Then a, b, c together must be 4. So this is how we get the first equation here. Now the second one is -b plus c in front of x, but we know here is -1, So -b plus c has to be -1. Now then, -a has to be -13. This is what I wrote. -a here has to be -13. You may do, mark it. Okay. Yeah. So then -a is -13. So both sides multiplied by -1, negative, so you get positive a. -1 times -13 is 13. So a is actually 13. Now we are glad right here a is out to be 13. Then this one is 13. So 13 plus b plus c is 4. And then both sides subtract 13. We know we can cancel these two numbers. And b plus c equals -13 plus 4 is -9. So now we have a b plus c is -9. And minus b plus c is -1. And then we name the first equation is 1. The second equation is 2. Now look, if 1 plus 2, what do we get? That's the first equation, add onto the second one. Positive b, negative b will be cancelled. And one c, another c together, there are two c's. Okay? And then right-hand side is -9 plus -1. We have -10. And then both sides divided by 2. 2 divided by 2 is 1. Times c, 1 times c is c. And -10 divided by 2 is -5. So we are glad what? C is -5. And we already know what? A is 13. So our business is to find b. How? -5 is c, you put it back. So you have a b plus -5 is -9. Both sides add 5, you may cancel positive negative. Then you have a b stands alone on the left. Right hand side is -9 plus 5 is -4. So we then have all three values. A is 13, you put it back here. And b is -4, you put it back here. and C is negative 5, you put it back here. That will be the final answer. Okay? Please review this lecture. I'll see you next time.